If you have a function, then the inverse function to that is a function that will undo this function. So you have this function. If you plug in x, you will get out y. If you're given y, from what x did that come from? That is given by the inverse function. The inverse function you write like this. If you put in y into the inverse function, it will give you the x that gave rise to this y. So these are like opposites. Note that this does not mean 1 over f. So this does not mean that. This is just a symbol for the inverse function. For example, if you have the function y equal to x squared, if you limit the definition of this function to non-negative numbers, then this function will have an inverse function, which is given by the square root of y. So this is x. Let's take another function as an example. Let's say instead you have this function, and this function is just defined for three numbers, 0, 1, and 2. So you see for 0 it gives 4, for 1 it gives 1, for 2 it gives 3.5. Then the inverse function of this one is this one. So you just reverse the arrows. So you see that if you plug in y equal to 1, then we get x equal to 1. If you put in y equal to 4, then you get x equal to 0. And if you put in y equal to 3.5, you get out x equal to 2. So the inverse function undoes the function f. So if you have a function f of x and its inverse function, if you put in the inverse function into f, it will give you back the number you put in from the start. And oppositely, if you put in the function into the inverse function, it will also give you back the number you started from. So these two undo each other. You can state that more abstractly in terms of function composition. So if you take the composition f and the inverse, or inverse and f, they will be equal to the identity function. And the identity function is a function that will give you back the same number you put in. If we, for example, have the function f of x equal to 2x, then the inverse function is given by y divided by 2. For example, if I put in 3 to the function, then I will get out 6. And if I then put in 6 into my inverse function, it will give out 3. So it will give back 3. To find this inverse function, I could just start here with my original function. Then I can solve for x. That will give me the inverse function. For example, if I instead had f of x equal to 2x plus 3, then I can just solve for x. And that will give me y minus 3 divided by 2. And this is the inverse function. Note that if we have an exponential function, the inverse function is the logarithmic function. So exponential function, logarithmic functions are inverse functions. For example, if we have e to the power of x, where e is Euler's number, then we have the inverse function, the natural logarithm of x. We see that these two figures are just the mirror image of each other in this line here. Note that not all functions have an inverse function. For example, this one does not, because we see that for x equal to 0 and for x equal to 2, they will both give out 4. So we cannot have an inverse function because here it's ambiguous which number y came from. So here it's ambiguous from where 4 came from. And that means that there is no inverse function. If there should be an inverse function, we must have what is called a bijection. And the function is a bijection if for every number we get a unique number out. And for every number here, we have a unique number it started from. So for bijection, it's not ambiguous which number something came from. So in this case, we have an inverse function. And to get that inverse function, we have to switch the direction of the arrows.